One of these is an ER collet. The other is a broken belt buckle, or if we're lucky, an old mattress spring in the shape of an ER collet. One of these does exactly what you'd expect it to do. The other one? Well, the other one could haunt you for the rest of your life. Or at the very least until you throw it up against a wall in a fit of rage. Can you spot the difference? Neither can I. And that's how they get us. Welcome back. I'm your host, This Old Tony. And although today we've got a short video, probably a short video, I've been wrong before, this might just be one of the most important videos I ever make. Today, I'd like to share a lesson so important that I make time at least once a year to relearn it. Lest I lose anyone in generalities, let's get back to collets, the sphincters of the machine world. Now, this video isn't really about collets, even though it is. But what are collets? You might be asking your significant other, or your kids maybe, talking out loud to your goldfish. Well, I don't know. But I can tell you all of the collets on this planet are round. And at the risk of sounding circular, a collet is just a collet. I mean, come on, cut me a break. Collets are round, often segmented holding devices. They're typically used to hold tools or work pieces, but let's not paint ourselves into a corner. Here are a few different size ER collets. These are all ER collets, just different sizes, which is why I said the last sentence the way that I did. But this is an R8 collet, and this is a 5C collet. A Dremel collet. I think this is a router collet, though that might be from a die grinder. A pin vise collet. A few different sized collets for a TIG torch. I've got a God only knows what this collet is collet. A border collet. The list goes on forever, but based on that last joke, I'll stop there because I can't think of any more. Should you find that you can't satiate your bloodlust for collets, check the good book. Here you'll find just about everything you want to know with all the important details, including the ER collets that we'll be talking about today. And at the risk of boring some of you, collets fit into a matching holder. The taper and geometry on the collet have to match the taper and geometry in the holder. This 5C collet, or 5C collet to ER32 adapter, are drawn in from the back. So you'd install this in something like this block here, and there's a ring somewhere that would draw this collet and lock it into the block. Same thing with the ER collets. This is a 30 taper, goes in the small milling machine, and this is ER32. I really should have cleaned these ahead. Same idea, collet goes in the matching taper geometry, except this one is pushed in instead of being drawn in from the back. Now yes, with this particular collet, you'd want to snap it in to the collet nut first, then wind it in. And whether they're drawn in from the back or pushed in from the front, the matching tapers cause these little slots to close. You're not going to see that by eye, but as I push that in there, that center bore will tighten because science. Again, you'd usually do this because in this case, you'd want to hold a tool of this particular size, 1/2 inch, so that you can mount it, in my case, in a milling machine. This is a small end mill. Small for me anyway. And I'd like to use this to cut a 1-inch keyway in this 2-inch steel. Yeah, I'm just kidding you. Ribbing you. Funning you guys. I want to mount this tool in my mill so I can do something with it. Maybe cut a little O-ring groove, or who knows, maybe misspell someone's name in a set of screwdrivers. Sky's the limit. Unfortunately, my mill won't take these small cutters directly. I need an adapter to go from this size to this size. Fortunately for me, I have an end mill to milling machine adapter. I have quite a few of these, don't tell my wife, and this one happens to be 40 taper on this end and ER16 on this end. This goes in the machine, this holds the end mill. I also have an ER16 collet for that end mill size. How serendipitous. We'll put the collet in the collet nut and the end mill in the collet. This machine happens to have a hydraulic puller thingy that keeps this in the spindle. Yours might have a threaded drawbar. In any event, there we have it. Tiny end mill, not going anywhere, solidly loaded into the machine and ready to go. Or so I thought. Quick but relevant backstory. I've now probably gone through $80 in small end mills, snapping them one after the other, pulling my hair out, going crazy trying to dial in the feeds and speeds. I was convinced I had something wrong. I was doing something wrong. But the thing is, and I'm no psychologist, they kept snapping unpredictably. At first I thought I was feeding them too fast, then maybe running them too slow. Was my max spindle speed too low? Maybe it was the coolant, or lack thereof. Too much of a depth of cut? I mean, I had no idea. I was frustrated. I got to the point that I was questioning if this was even the right hobby for me. Breaking tools sure can take the wind out of your sails, especially in my case. I don't even own sails. How frustrating is it when you just need to do something quick and simple and it turns into a whole expensive thing? Consequently, I spent weeks just generally bummed out, moping around the house, dragging my ugly mug across the floor, trying to figure out what I was doing wrong. Every time I thought I had it figured out, I'd come back to the garage, all excited, snap a few more end mills, and then mope back into the house. When, one night, just hanging out on the couch, out of the blue, my wife looks over to me and asks, "Old Tony, have you checked the run out on those tools?" The run out. I had not checked the run out. To be honest, I didn't even know what run out was. I had to look it up, but sure enough, check this out. That's 2 thou run out. 2 1/1000ths of an inch, for crying out loud. And keep in mind, this is after I tuned things up a bit. This was almost 4 thousandths out. 3.5 or so, if memory serves. I know what you're thinking. 3 thou? That's nothing, old Tony. That's less than the size of a human hair. I know you're thinking that, because if you weren't, you would have stopped this video 2 minutes in and never made it this end mill is not running concentric to the machine's spindle. As we saw, it's currently offset by 2 thousandths of an inch. Remember, it was worse. But let's talk about why that's a problem. Let's talk about why lack of concentricity is an issue. But to do that, we'll have to go back to the bench, because there's no way I'm talking standing up on a Saturday. Okay, so your end mill isn't concentric to your spindle. It's running out. What's the fuss? Well, first, maybe most obvious, your tool, if it survives, will cut oversized. Imagine this 1/2 inch tool having 1/2 an inch of run out. That means as it's turning, it's also wobbling 1/2 an inch. It would cut a 1 inch slot. It wouldn't cut a 1/2 inch slot. It'd swing a 1/4 inch both sides of nominal. It'd basically be a boring head or a fly cutter. Now 1/2 an inch is an exaggeration, of course. If you really had that much run out, I'd step back a minute, make sure you're actually standing at your milling machine and haven't accidentally installed an end mill in your KitchenAid. But let's get back to our situation. I had a 3/16 end mill. This isn't it, but for argument's sake, I had a small 3/16 end mill with 2 thou run out. Let's assume we're the sort of machinist who doesn't get hung up on exact dimensions. So no big deal, our tool is cutting 2 thou oversize. Well, not so fast there, tool snapping, unemployable machinist. If it's a big tool, say you've got 2 thou run out on maybe a 3/8 end mill, the tool might survive and probably cut just fine for a little while. Or if you're cutting soft materials, for example, again, you might get away with it. But my end mill, plural, were smaller. What's the permissible load of a 3/16 carbide end mill? Well, I have no idea. So let's look it up. 1/1000ths of an inch. A 3/16 carbide end mill, cutting mildish steel, can handle about 1/1000th of an inch per tooth chip load. That means at an acceptable depth of cut, at the right RPM and feed, it's designed to cut 1/1000th of an inch per tooth on the end mill. Half that in the material I was trying to cut. So 5 10,000ths of an inch per tooth, or flute. If I was looking at 3.5 thou run out, that means my chip load was 7 times higher than what the poor tool can handle. Even with 1 thou run out, at best we're looking at twice the permissible chip load. So if it were perfectly concentric, spinning at the right speed and the correct depth of cut, the end mill would be moving at a feed rate such that each flute was taken off 1 thou, or 1/2 thou, or whatever is right for your end mill. But if it's got run out while it's spinning, Some part of the time it's taking more than that chip load when it's wobbling into the cut, and sometimes it's taking less than that chip load as it's wobbling away from the cut. Smaller end mills, smaller margin for error. There. I'm glad we went through all of that to state the obvious. Since we're here, it's probably worth saying that a 1/2-inch end mill could probably handle 5 or 6 thou per tooth. But I doubt any of us hobby folks are running our machines that hard, so consequently, our tooling likely survives. So maybe not usually an issue, if we're not concerned with tool life. But that's a whole different video. So, okay, why do we have so much run out? And what can we do about it? The first part of that question, let's say, has an easier to swallow answer than the second part. There's a few reasons you might have run out, but in my case, I know exactly what caused it. Poopy collets. Just so you don't think I'm blowing smoke up your tuchus, there's the same size end mill installed in a not poopy collet, both of which are installed in a name brand collet holder. Let's see how it does. Can you make that out? Neither can I, but it's less than 1/2 of an inch. Less than 5/10, probably 1/2 5/10, half the resolution of this indicator. Sure, I could crack open the safe and get the quantum indicator out, but good collets, generally speaking, are rated at 2/10. That's 2/10 of 1/1000 of an inch, or as the French like to call it, 5 microns. Here, again, we're probably looking at 3/10, for lack of a better number. Hard to say, but good enough for my milling needs. Certainly better than 3/1000. Some might even go so far as to say 10 times better. Short story long, I penny pinched my way to a set of cheap collets. And now I'm paying the real price. I needed some collets, didn't want to spend a lot of money on them, just went online and bought the first set that had 4 stars or something. I think it was a 10-piece. No, it might have been an 11-piece set of ER16s, which cost me $30, less than $3 a collet. Now, I certainly noticed the more expensive sets, but in my infinite wisdom, figured I didn't need them for anything critical, and here I am today paying for that mistake in expensive broken end mills and mental health. I know, I should have known better and just bought the good collets, right? Certainly if you do this stuff for a living, trying to feed your kids, that sort of thing, that's what you do, buy the premium stuff. Buy once, cry once, isn't that what they say? Too poor to buy the cheap stuff. But take off your safety glasses a minute and let me hit you with a counterpoint or two. I am by no means endorsing cheap junk, but consider the following. If you buy good collets, you'll probably want to put them in a good holder. A good collet of this size, ER16, is probably $15. 5 times more than what I paid for mine. I'm kind of guessing there, but it's probably closer to $15 than it is to $3. That's the point. And the name brand good quality collet chuck for that collet? Forget about it. Depending on the taper size, these are a 40 taper. Depending on the taper size, you'll probably be staring at the heavy side of $150, which doesn't even include the dumb pull studs on the back. That doesn't even take into consideration that you'll likely need multiples of each collet. You think you're buying just 1 1/4-inch ER collet? Think again. Take all of that and multiply it by however many tools you think you'd like to set up for your milling machine. Got 10 holders for 10 tools? Heck, I wouldn't know how to even start doing that kind of math. But okay, yes, the grown-up in me understands that in the long term, buying the good stuff is cheaper than breaking end mills or, God forbid, scrapping parts. But the kid in me is living in the short term. There's not that fine of a line. What about vices? You're not going to need just collets. You're going to go for the best vise money can buy? Parallels? Drills? Reamers? Starrett hair gel? Where do you draw that line? Here's the thing maybe. There used to be a time where it was reasonable to expect that the product you bought would do what it said on the tin. I mean, these are collets for crying out loud. Their only job is holding tools straight. Don't have money for the solid gold ones? Fine. Maybe the cheap ones are made out of old soda cans. Maybe they wear out sooner. Fine. But 3, 4, 5 thousandths run out? I mean, come on, I paid good money for... Okay, I'm sorry. I apologize. I got worked up there for a minute. In hindsight, I realized what I pay for these probably doesn't even cover the plastic baggies. But when did it become okay to sell trash? Granted, these things got a, I don't know, 4-star review. Maybe I got a bad batch. I don't know. It's the world these days, I guess. It's a balancing act. Maybe for light-duty routers, cutting wood or plastics, the cheaper stuff is okay. You could make the argument that it's good to learn with, but be careful. It's a slippery slope, right into the land of frustration. Now, granted, I do buy most of my stuff used. All of this stuff except the end mills and this crappy collet is secondhand. eBay, flea markets, machine resellers, and the like. And just so happens that most of that used stuff, if not completely worn out, is usually pretty good quality. Sometimes outstanding quality. Probably because otherwise it would have probably been thrown out long ago, right? Okay, so now I feel a bit silly. I'm sitting here all worked up, trying to remember where I was even going with the story, but maybe that's about it. Maybe I just got frustrated and needed to vent. Thank you for giving me a shoulder to cry on. While we're here though, if you do end up buying some junk like I did manage to save a couple of the ones that I needed, the ones that I opened. Some, like the one we saw in the mill, are just pure garbage, destined right for the trash. I mean, don't get me wrong. If it's not too late, send them back, of course. But if you've got them, or if that's all you're really willing to spend, maybe you can fix them up a bit. On the couple that I opened, I noticed, at least on this set anyway, the burrs were pretty bad. Same on this one, you can feel them just right out of the package. They ran their slitting saw through this, cut the slots, and sent them right to nickel plating. A little bit of work on some of these with a stone, knocking down those sharp edges, made quite a difference, to be honest. Don't go nuts on the curved sections, but take all the burrs and the bumps out. Of course, you really shouldn't need to have to do this. One other thing you can try, if you've got a match made in heaven like I do, between a crap collet and maybe not the best collet chuck, I'll do this without the nut. You can try indexing the collet in the holder. It's a pain in the butt, and you'll probably forget about it when it comes time to change out the tool for a new one. But if you want, you can mark them and try to balance them. Think of it like balancing a tire. Install the collet in one orientation, give it a try, check your run out. If that doesn't work, turn it a bit, put it all back together again, measure the run out. You'll get a feel for maybe it's getting better or worse, and just kind of keep indexing it around until you find that sweet spot where the error in the collet is canceled out or minimized by the error in the holder or the error in your spindle, wherever that error is in the stack up. I got lucky, quote unquote, on a couple of mine. If I can even use a word like that in this situation. By deburring a little, messing around with the rotation of the collet and the chuck, I could get it down to less than half a thou. Not spectacular, especially for these small end mills, but what's a kid to do? Now, none of that will work, of course, in a good collet chuck. If you've got a name brand collet, that's right on. I mean, you could use this same clocking trick to try to get that 2/10 out, but if your collet is bad and you put it in a good holder, you got to just put up with what you paid for, I guess. Well, my heart rate's come down. The ringing in my ears is a little better, so that's probably all I've got. I'm still confused as to what it was exactly I set out to say when I was going to make this video. This might be just one of those I spent a lot of time editing and putting right in the trash. But on the off chance it made it to YouTube, thanks for watching.